All right, so my talk's on solving interoperability and controllability with standards for dAI agents. And today we're really at like this inflection point where in AI development where the bottleneck is not like the model capabilities, it's really around coordination. So as we move into this world of autonomous agents, we start to sort of abstract ourselves from single model architectures to multi-agent systems that need to collaborate, coordinate, and act in unison. And when you move into these sort of networked ecosystems, the problem space changes drastically, right? We open a whole can of worms of new challenges, right? In interoperability, in trust, identity, verifiability, and economic alignment, because these really fundamentally need to be solved for us to move into this agentic economy. What we're building now looks increasingly like a parallel internet. I rewind to 30 years ago, 28 years ago, and having gone through this previously, we needed to build a more robust protocol stack to be able to handle the challenges and market capture when vendors were trying to look to own the network, like fundamentally own the network. So, and the only way we could get to this point of abstraction was to implement a more robust TCP/IP stack and allow innovation on top of these protocols. And so I would say that agentic AI needs something equivalent, right? What we have today is a lot of the framework and the groundwork and pieces that we need to solve the problem, but we need to build on top of this. And so this is super important because we want to create new economic domains, these sort of ideas of higher degrees of autonomy, and really build out a strong Internet of Agents economy. And we're seeing that now with the emergence of protocols, mostly disaggregated, but with some overlap, like MCP and A2A and the agency framework as well. And they all sort of solve different parts of the interoperability surface. So I think what we're building today is a very foundational stack that will allow us to have agents discover one another, verify identities, offer transparency, verifiability, coordinate actions, exchange value, and do a lot of bring a lot of agency to what folks are looking to do within this new economy. So the promise of agents is pretty straightforward, right? Does anyone want to take a stab at telling me what it is? All right, well, that's the same answer that I have. We're sort of like collapsing, I guess what we would call, collapsing orchestration into autonomy. So instead of taking predefined workflows, we allow intelligent systems to make those decisions for us on our behalf to varying degrees of autonomy, right? And so they can chain tools, connect to data sets and data sources, oracles like APIs, infrastructure, and work with other agents together to form consensus and to act on our behalf. So at the same time, this autonomy creates value, but it also fragments the ecosystem. Every vendor is shipping different frameworks, proprietary runtimes. These create closed swarms, locked tooled ecosystems, and proprietary memory representations. So like shared memory becomes a real problem. And as in the first wave of the computing paradigm, always early silos look like innovation, but at scale they fall flat, right? There's friction and there becomes a lot of capture. And so that's where value stalls ultimately. And then if we look at the governance layer, agents that act across boundaries raise compliance and trust questions, right? That can't be solved purely by product policy. they have to be solved at the protocol level. Like we have to go down deeper. And this is where we get this, shared infrastructure, the shared protocols that we can use to solve a lot of these real problems that we're going to face. And it kind of brings us back to the pre-HTTP era for those folks that, when the a little bit difficult to navigate. So I think what we really need to do is build like very durable systems built on open and shared protocols that are community owned. And this will ultimately create the substrate for the Internet of Agents. So open standards gives us a base layer that we can work with, right, for coordination. They guarantee that intelligence layer does not become captive to any single runtime. And we don't want to have to work with only one API service or one cloud provider, one hyperscaler. And so we need to create this substitutability, right? Being able to have one agent swapped out for another without having to rewrite infrastructure, create composability, so a new agent can do auto discovery and instantly be interoperable with the network that it's within. And we don't really want to have to go through and integrate over and over and over again. So I think it's very important that we create these levels of abstraction. And so there is going to be an HTTP moment for agents. I don't think we're there yet, to be honest with you. Some may argue that MCP or dAGI have solved that. I think we're still at this, this stage where we have to come up with something that is very much more broadly adopted and widely recognized. And so agents need portable context, they need portable memory, they need portable identity, portable capability. There's a lot of things that agents need, and I think we can only get to those in a multi-agent architecture, in a multi-agent world, when we have cooperation across organizations, right? Whether big tech or individual developers, but folks working together in the commons. And so, critically for crypto native applications, open standards also enable trustless execution domains. So because once agents can become independently verifiable and identity bearing, we can layer payment, staking, incentives, and coordination primitives on top without needing a central broker, which is key, right? And the network fundamentally becomes the platform. So MCP, dAGI, agency, they sort of form a layered architecture. Not really competing standards, but obviously we're very early days here. MCP is sort of the agent to tool layer. I'm sure you're all very familiar with it, MCP. And this is how reasoning systems request capability from the world, right? dAGI is that coordination layer when we talk about multi-agent systems and how agents speak to each other in a common language. And then the other piece of this is agency, which is sort of it has a protocol in there called SLIM, but and there is a little bit of overlap with dAGI, but the agency itself is a more robust framework and addresses a lot of the very important factors in a sort of a decentralized agentic world, and I'll get to that a little bit. So I think what's important is this stack is not really theoretical at this point. It's happening in the open. All of these projects are community run. They're multi-vendor. You can actually make, issue PRs and contribute to the projects. And the governance boundary is very neutral. It's very vendor proof. So I would strongly encourage you to get involved if you can. And you don't really get a stable internet if one company is building out this Internet of Agents, right? So we just need to really spread this very communally across the world. Just see what slide I'm on here. All right. So MCP solves the most immediate pain point, and clearly why it emerged last November, which is tool fragmentation, right? So historically, each agent runtime needs bespoke adapters at every tool. That does not scale. It produces the same integration bloat that we dealt with microservices, and we had to solve that through standardization, right? So with MCP, an agent doesn't need to know how a tool works, right? It only needs to know that how it's exposed to the protocol. And so this allows dynamic capability expansion. New tools become usable without refactoring the agent itself. And MCP also embeds governance primitives, so it's got context, boundaries, permissioned access, and auditability. A lot of folks joke that the S in MCP stands for security, but security can be solved at different layers, right? So one of the things that becomes really critical here is that to operate across monetized systems or when privacy domains differ, we need very robust governance, right? MCP is structured to scale horizontally, so dozens, hundreds, thousands of different tools, all addressable without implicit coupling. So as long as it's MCP compliant, it should be able to pull context and be able to interoperate. Why do I feel like the slides are not in order? All right. Okay, so if MCP is how an agent touches the world, then A2A is how agents shape the world through cooperation. A2A allows agents to form networks, ephemeral or persistent, and to negotiate, coordinate, and exchange state with other agents and share work. So this is where we move from single agent intelligence over to the multi-agent economies. Technically, A2A is built on battle-tested primitives, HTTP, SSE, JSON RPCs, so it doesn't require proprietary Rail adoption. It's backwards compatible with existing enterprises and forward compatible with decentralized architectures. And I think that's why we're seeing a lot more traction now. It's replacing sort of bespoke infrastructure, and it's giving a protocol for intelligence level communication. From a decentralized systems perspective, I would say A2A is messaging, sort of like that messaging substrate that will enable agent markets. Agents discovering other agents. I'm not sure, is this on? Through app directories, through identity and discovery protocols. And there's still a lot of space to fill here, as we move from the sort of concentric enterprise sort of architectures into a decentralized space. So I'm not saying that everything is solved already, but this creates tremendous opportunity for folks to be able to innovate and create new methods and new extensions to some of these protocols. All right, so what's powerful here is really the complementary. MCP standardizes how agents touch capabilities like tools, APIs, databases, infrastructure, and A2A standards the communication layer, right? We talk about coordination and agent interoperability. So when you combine them, you get sort of full spectrum, action and collaboration. So without MCP, agents can talk, but they can't do anything, and with A2A, agents can act, but only in isolation. And so together, when you turn AI from a closed loop computation into an open coordination system. The architecture is layered by design. So MCP is effectively a capability plane, while A2A is communication plane. And this is very close to execution versus settlement layers in DeFi. One provides programmable action, and the other provides discoverable and verifiable coordination. And this pairing is also what opens the door for trust minimized systems. So when you know who an agent is, their identity and provenance, what it can do, its capabilities, and how it will communicate with the world, the protocol, you have sort of the fundamental building blocks for autonomous economic behavior. And if we're going to build this great agent economy and full autonomy and full of agency and just this grand vision, we need to start with all these sort of very primitive building blocks. So the third project I want to mention here is agency. So I mentioned it a little bit earlier, but I think this solves a critical next layer in this evolution. really, which is like identity and discovery and more of a decentralized or outside the enterprise architecture. Without identity, you have no trust domain. Without discovery, you have no market surface area. Agency gives you, cryptographic identity. It's portable, verifiable, and it's not really platform bound, right? It's an open standard. And so this means like things like reputation, behavior, capabilities can persist across ecosystems instead of being trapped in walled gardens. It also introduces routing and discovery, which agents exist, which capabilities they advertise, and under what terms they can be invoked. So in Web 2 sort of vernacular, DNS, OAuth, and telemetry. In Web 3, like DID, service registry, and verifiable state. And this is what transforms a collection of isolated nodes into an actual usable network. And finally, agency brings observability. So, observability is what enables governance that's decentralized but enforceable. This is part of the enterprise world, but like industry-wide, we would consider this compliance. And so I think this ability to have fundamental protocol level debuggability is absolutely crucial, but also having the transparency to understand what is the agent doing, why is it doing this, how can I trace this back, because there's a lot of things that can go wrong with agents. So one of the biggest misconceptions is that governance is fundamentally overhead. In decentralized intelligence systems, governance is throughput. If an agent cannot be trusted, it will not be called. If it cannot be inspected, it cannot be coordinated. And if it cannot prove scope, it cannot be granted credentials. So trust is really a scaling constraint. It's not a philosophical one. And this is why governance primitives need to be embedded at the protocol layer, not layered as policy after the fact. So MCP gives capability bounded action, and dAGI gives authenticated coordination. And so agency would give identity and auditability, and if you stitch these all together, you create a certain degree of controllability without centralization, and which is the key requirement for moving from agents as assistants to agents as infrastructure. This also prevents the outcome we saw in Web 2, which was dominance of through these enclosures and walled gardens. And so the question then becomes instead of who owns the platform, the question really is who best implements the protocol. And interoperability creates competition on implementation merit rather than on market lock-in. So once identity and interoperability and governance are standardized, the next logical step is economic alignment, at least for y'all folks. Because autonomous coordination without value exchange is fundamentally incomplete, right? This is where X402 and A2P come into play. There's some other emerging payment protocols that have kind of come up in the last 3 weeks. But ultimately, these two are sort of where most of the eyes are at right now. So if you haven't heard, I'm sure you may have heard, but X42 provides provides programmable money flows, right? So it's not payments as external events, but value transfer as part of the execution path. A2P defines how agents interact with payment rails, on-chain, off-chain, stablecoins, settlement networks, so forth. And all of this with cryptographic verification and auditability built in. So for agent economies, this is essential. If an agent can call a capability but cannot compensate the provider, the system collapses into subsidization. If an agent can request scarce compute but cannot stake or escrow, then there's really no Sybil resistance here, right? Payments are not an add-on, they are an incentive mechanism that turns coordination into fundamental economics. This is also the bridge between AI and DeFi. Agents become not just consumers of economic infrastructure, but they become actual participants in it. And so they can execute, arbitrage, negotiate, and pay in real time. So when you zoom out, this is how autonomous services become high-value markets. And once these layers are combined, the architecture shifts from platform-centric to network-centric. Instead of agents hosted inside a platform, we have agents existing as peers across infrastructure. And so this mirrors the exact evolution of distributed computing. We started with centralized, then we moved to federated, and then we moved to decentralized infrastructures. So decentralization here is not like strictly ideological. It's really resilience and a scalability property. Agents at the edge can act locally without latency to a central broker, having to make call homes. Agents in cloud networks can coordinate macro scale functions. And because identity is cryptographically rooted, trust does not require custodial control. So this also introduces a new design space for market-driven optimization. Compute becomes liquid, right? It's a commodity. Capabilities become tradable, service quality becomes reputation-backed, and economic alignment emerges not from contracts between companies, but from protocol-level guarantees between autonomous actors. And so the path forward is not one company launching like the agent platform. Some companies, may want you to believe that, but it's in fact the exact opposite, right? It's coming together a vendor-neutral community with open governance, so many agent ecosystems can interoperate and innovate. And this is exactly how Linux, Kubernetes, and PyTorch achieve global scale adoption through neutral governance, open infrastructure, and ultimately creating durable ecosystems. So in the agent world, neutrality is not idealistic. It's required for composability. No single vendor can own the entire stack. Reasoning, action, communication, identity, and settlement. Each layer must be portable. And so the Linux Foundation's role is not to build the end state, it is to maintain the commons on which everyone can build. And the internet was born when we standardized communication, right? The internet of value emerged when we standardized cryptographic settlement, and the internet of agents now requires standardizing interoperability. So intelligence can become a network resource, not a product silo. And we're still in the early days here, right? But the direction is clear. Agents will not scale by enclosure. They will scale by protocol. If you were building tools, runtimes, networks, or permissionless economic infrastructure, then you're already building part of this future. The next decade of AI will belong to those who build in the open, because only open systems can become shared infrastructure at planetary scale. So thank you very much, and I look forward to building the next layer of the internet with you.